In this video, I will teach you how to build metadata-driven / configurable notebooks in Microsoft Fabric that will significantly boost your development speed. Also, I will show you how to parallelize code execution in these notebooks as well for way faster processing. This is a video you definitely want to watch in order to level up your data engineering skills. Welcome to the video. My name is Aleksi and on this channel I cover Microsoft Fabric and Azure related topics. In this video we're continuing our journey with Microsoft Fabric data engineering and today we're covering metadata-driven / configurable notebooks. If you'd like to check out other videos in this series, the link to the playlist can be found in the description. In many data engineering cases, you could be processing many files or tables with one notebook, and hard-coding logic for each table or file can get time-consuming and result to a very messy code. For this reason, I love using metadata-driven / configurable notebooks. In a nutshell, this means that I just define a configuration for the notebook, and then I have some type of iterative logic in the notebook that will go through that configuration and then do operations based on it. In my opinion, this kind of approach speeds up the development process significantly, and adding new files or tables to the solution is way easier since most of the time that means just adding a new configuration item rather than changing the code in the notebook. I know that this concept can be quite hard to understand if I just try to explain this to you with words only, and for this reason, like always, I have prepared a demo / tutorial to demonstrate this concept in action. Also, all the files and the notebook that I will be using can be found by clicking the link in the description. Let's get started. Let's start from my lakehouse where I have this new folder in the file section called Fabric DE Series 34, and in this folder I have two subfolders, config and source. In the source folder I have two CSV files. In both of these CSV files I just have few rows of data and the header. So these are very simple CSV files. And in this config folder I have this config.json file, and this describes the data processing configuration for both of those files. So basically we are describing here what is the file name and what is the destination table for that file. And then we are also telling the write mode. So do we want to overwrite the data when we write it to the table, or do we want to append the data? In this case, I have described that I want to overwrite the animals data and append the movies data. We can see how this works out when we start to build the notebook where we are going to use these configurations. Then also in this configuration folder, I have this other config file that we are going to use later on in the demo, but we're going to check out this file when we are going to actually use it. But now let's go to our notebook. In this notebook I'm running first this setup cell, and here I'm importing this JSON library that will be used to read that configuration file to the notebook, and then I'm defining some file paths that will be used to read and write data, and then I'm also defining the config file name here, and then I'm also creating a schema if it doesn't already exist where I will be writing those tables in this tutorial. Also, if you're wondering how to get these file paths here, I have this same lakehouse that I just showed to you as a default lakehouse in this notebook, and we can go to the files folder and click these three dots, and here we can find these paths here. So basically this relative path for Spark is that Spark path there, and that file API path is that first file API path that we have there. But yeah, this is how you can get those paths. But now let's run this first cell here so that we have our setup ready for this tutorial. And in this cell, we're actually reading the configuration file. And now somebody could be wondering why I'm using configuration files and not configuration tables that some people are using. And my simple reason for that is version control. Since using these files and adding them to the version control is way easier than adding data in a database table or a delta table that would be used for the configuration. So I prefer using files. And now we can run this cell and read that file to a list. And we can see that now that configuration is in a list here in the notebook. And we can see that that list contains two dictionaries if we are using Python terminology. So we have a dictionary for each file that we are going to process. In the next cell, I'm just demonstrating how we can loop through this list and how we can fetch configuration items from that dictionary and what kind of reference is needed. So basically here we're just iterating over that list and printing some stuff. And as we can see, now we were able to fetch each configuration out from that list by using this simple for each loop. And with this example, I'm just showing you how to get those configuration items out of that configuration. For example, we can get the source file by referring to the source file key in the config that we are iterating over in this loop. But here we can see that configuration printed in more readable format. In the next example, we are expanding that example a bit, and this time we're actually already reading the data using this dynamic file path. Basically, we're getting that file path that we defined in the setup and adding a source there, and also that file name that comes from the config. So we are reading both of these files in this loop when we run that, and then also displaying the data. And just a quick note here, we are not now defining any settings for reading the CSV file since we have standard CSV files. But for example, if we would have a situation that we would have a header in another file and no header in the other file, we could actually have a configuration property that would define do we have a header for the file or no, and then use that property here dynamically to decide do we have header or no. Just keep in mind that I'm using these very simple configurations here in order to demonstrate the concept and not dive too deep into these configurations. But basically this configuration would allow you to build very dynamic notebook. But yeah, let's run this cell and let's see that we can read that data from the CSV files correctly. And there we can see that we managed to read that data well, and the data looks good. So everything works so far. In the next example, we are no longer displaying the data, but in this case, we are already writing that data to the lakehouse table. And as you can see, now we are using that write mode property from the configuration when we're defining the mode for our writer. And here we are passing basically the mode append or overwrite. And then based on the configuration, we are doing different operation per file. But yeah, let's run this cell and let's see that everything works. And now our code is done, and we can check out that now we should have two tables here. And there we have animals and movies tables. And in this cell, we are wrapping our logic to functions in order us to have more cleaner and modular code. So basically here we have two functions for reading the configuration and writing data to the lakehouse table. So basically we are just using the same code that we had previously there, but now wrapping it to functions in order us to have more modular and cleaner code here. So nothing magical here, we just like to keep things nice and tidy. And in the next cell, we are using both of these functions. So first we are reading the configuration based on the configuration path, and then we are looping through that configuration list that came as a result from that function, and then we are running in that loop that writes CSV file to LH table using the configuration. And this way we can keep our main logic here shorter. And now let's run both of these cells and see that everything works fine. And again, our code is running and should finish quite fast. And as you can see, now we are processing these files one by one. And imagine if we would have, for example, 500 different files. This would actually take quite a long time. Next, I show you how you can optimize this process by using parallelization. But before we do that, I would like you to know that I spent a ton of my free time creating these videos for you. And that's why I would like you to hit that like button and subscribe to the channel for more Mixed Fabric content. It doesn't cost you anything, and I would highly appreciate that. But now let's continue with the video. In the next cell, we are again wrapping the logic to the functions, but this time we are actually going to use this concurrent features library. That is this very powerful Python library for creating parallel processing. And I'm not going to dive too deep into this library in this video, since I have a dedicated video on this and how to do parallel API calls using this library. So if you would like to get more of a step-by-step tutorial how to use this library, I would recommend to check out that video and going through that tutorial before continuing with this one. Here we are importing some things out from the concurrent features library, for example the thread pool and as completed, and then again we are having this read config function, and then we are having this write CSV file to LH table parallel function, and in this function we are having this try and except logic here, because the parallel processing really needs this, since we are not running these files one by one. Instead of we are running them in parallel, and we need to have some logic that will handle the errors if we have any. So we are not going to stop the execution immediately when we run into an error. Instead, we let all of those processes run, and then we are going to go through, did we have any errors in any of those file processes? And for that, we have this handle errors function that will actually go through the result of our concurrent futures processing and check, did we have any errors, and then print out those errors if we had any of those. But yeah, we will see shortly how does it work. But yeah, let's run these functions so that they are defined. And then let's check out this last cell here. Here I'm defining the config file name. And the reason why I'm defining this config file name here is that I'm going to change it shortly to another config file that has an error there so that the process will fail, so that we can see how does the error handling work. But yeah, basically we're here doing pretty much the same thing. So just reading the configuration, and then we are going to use this thread pool executor that is going to actually handle the parallel processing. And for that, I'm defining max workers to be 2. So in this case, we are going to have 2 parallel processing running side by side. Also, a good thing to note here about this parallel processing is that it will run on the driver node of your Spark cluster. So basically your driver node CPU is the limiting factor how many parallel processes you can be having at the same time. There are also other ways in Spark to parallelize things, and if you have really big data and you're running this on a huge cluster, I would recommend looking at Spark UDFs or Spark user-defined functions that we're not going to cover in this video. But that is just a tip for you what to look for if you are having way bigger data at your hands. But yeah, with this we are running 2 parallel processes at the same time, and we are executing that write CSV file to LH table parallel function in parallel, and then we're getting the return values out of those executions to this futures object, and then we are giving that futures object to that handle errors function that we defined there. And then we are checking, did we have any errors in those parallel processes. But yeah, more about these things in that parallel processing video that I have linked to the description. But yeah, let's run this and let's see what happens. And now it is actually running those processes in parallel. But with these 2 files, this doesn't really make that much of a difference. But we can see that we processed both of those files okay, and we didn't have any failures during processing. But yeah, now I will show you how does the fail configuration file looks in the Lakehouse. So we can check out that. So in this file, I have changed the write mode to this is not a legit mode for these movies files. Remember, we had that append mode here in the other configuration file, but now we have this so that the process will fail when it tries to write that data to that Lakehouse table. But yeah, let's go back to that notebook and let's try to run that with that fail configuration there. And let's uncomment that fail configuration and comment that config, and then let's run this and let's see what happens. Now this should fail, and let's see what kind of error message we get here. And we can see that processing okay for the animals file, but then we had some failures, and I have this custom print defined here so that we had an error with movies file. And I have defined the print for this custom error in these functions that I have here. So basically you could change these to whatever you want, but I prefer checking the errors after I have processed all the data sets in my metadata-driven notebook, since in that case we are updating the data that we can update, and then we are just throwing an error message for those data sets that we couldn't update, so that the end users in this case could possibly get already some of the data. But yeah, now you should have an understanding how to build metadata-driven notebooks and how to parallelize the logic in them. If you'd like to learn more about Fabric, check out this video next. Now I thank you for watching and see you in that video.